welcome to this video. We're going to be talking today about the idea of center of gravity. So let's get started. When we're talking about the center of gravity, the way we define it is that it's a point in a body from which the weight appears to act. So really what we're trying to do here is we're going to take a body, could be anything, could be a nice regular object or something irregular like our own bodies, and we're trying to work out, if we were to boil that down into one tiny point, where is the weight appearing to act? Now this is quite a tricky one. You can use this definition in your exams, but to really understand it, let's look at an example. Here we've got a nice regular shape. Now what we want to do is try and say, where is the weight of this shape acting from? If the shape has mass, you'll notice that it has mass at the bottom and mass on the top. So its center of gravity has to be somewhere between the top and the bottom. Similarly, it's got mass on the left and mass on the right, so the center of gravity has to be somewhere between the left and the right. Now fortunately, for nice regular objects like this one, the center of gravity is just the middle of the object. Okay, so when we're representing it there, we'd have a little dot or a cross there, and the weight which is acting down. Now notice the weight is always acting down. Gravity always pulls us down. That's going to be important later. You should be aware then that when we're dealing with a regular shape, this is just the geometric center. So if we had a rectangle or a square or a circle, we just simply find the geometric center of that object. For irregular objects, that's a bit harder, and we'll look at an experiment for that later. Why is it important? Well, let's take a situation where perhaps we tilt our object. Now notice I tilt the object, it's rotated a little bit, its center of gravity is in the same position, however, the weight is still acting down in this case. All right. Now, we have a situation here where we now have a pivot and weight to the left of the pivot. You can take a second to think, what would happen if I tilted this and then let go? Imagine I've pushed this and I'm just going to let it go. What would it do? Similarly, I might have it tilted like this. Again, we've got a pivot, but this time we've got a force on the right-hand side of the pivot. So just take a second, you can pause the video and think, what would happen if we let go of these two objects? Well, hopefully you've picked up that there's a difference in the direction of rotation between these two objects. Object on the left-hand side will rotate anti-clockwise. That's because the weight is going to make an anti-clockwise moment about this pivot. However, on the right-hand side, we're going to have clockwise rotation because we've got a clockwise moment due to the weight. So the position of the center of gravity is really important. Now, if I were to locate my center of gravity just above the pivot, then actually we would get zero moment, zero rotation, and that's something called an unstable equilibrium. We could talk about that later in lessons if we need to. Now, I've just said the word unstable, and this is really important for our course. So you've taken this on and you want to keep move on. We'll look on the next slide. If, however, you need a second to digest, please press pause and then carry on when you need to. So let's have a look at the idea of stability. Stability is a measure of how easy something is to topple over. So let's look at our rectangle shape this time. Now we've got two different configurations. We've got upright and kind of lying down. If you look there, you can see that we've got the same shape, weight is acting in the same direction. However, one of them is more stable than the other. Take a second to think, which one of these is more stable? Which one is easier to knock over than the other? Now, hopefully you've identified that this tall one would be easier to knock over. The reason for that, it means it's unstable, and that means that the one on the right is stable. Okay, now the reason for this is because the center of gravity is higher in our left-hand body than it is on our right-hand body. So we have the lower the center of gravity, the more stable it is. If you have something which you can orient in different ways, then it will be more stable if the center of gravity is lower. Now, that's one thing here. Now, another element here is we look at the base. You can see here that the base of this object is is narrow, and the base here is wide. And that's another thing that we can control the stability with. If we have a wider base, we have a more stable object. And to demonstrate this, let's have a look here at a different object. Okay, on the right-hand side there, you've got a triangle which is stable. Okay, it's stable because of two reasons. One, the center of gravity is low. Two, the base is wide. This is in equilibrium. The This one here on the left hand side is also in equilibrium. You can notice here our weight is just above the pivot. There's no moment. Okay. However, it would be very easy to knock over. Why? Because we have a high center of gravity and a narrow base. So hopefully that's clear. We've looked at the idea of the location of a center of gravity and then also its importance in terms of knocking things over and stability. Okay, if you're in my lessons, you'll now try the 3 multiple choice questions which are underneath the video. Thank you so much for watching, and I'll see you in the next video.